Hi there, and welcome to an update on our geologic situation in Iceland for Monday, March 4th. It is about 1:30 p.m. here Mountain Standard Time, 8:30 p.m. over in Iceland. I am geology professor Shawn Willsey. Thanks for joining me today. Appreciate the time you take to come here and learn with me as we dissect some of the ongoing activity there in Iceland. Want to also thank folks who were able to tune into my conversation yesterday with Nick Zentner, another really prolific and popular YouTube geology person that's out there. So if you haven't watched that already, I encourage you to watch that interesting conversation we had about science and public outreach and what we do and how we connect with people. Just a really enlightening conversation. But let's get right to the situation in Iceland. So we had some activity and some excitement over the weekend with a event on Saturday, March 2nd that did not result in an eruption, although in the moments leading up to as that situation evolved, it looked like an eruption was very likely, and I was among those who thought an eruption was among the most likely scenarios. As it happened, we had a flurry of earthquakes and seismic activity that never propagated upwards to the surface, and so we had magma move into the subsurface but did not move upwards and feed an actual eruption. So that's what we would call an intrusion, or what they're calling in some of the Icelandic media and reports are calling it a magma run. But in English, the more appropriate term would be an intrusion. We had magma that intruded into the rocks and moved through the fractures, maybe widening out the fractures, generating earthquakes as it propagated into other areas there. So what we'll do here today is break it down a little bit for you. There's a new update from the Met Office, some data to look at, including GPS data and such. And then I want to dispel a few things that were maybe floating around today on various social media platforms, and maybe add some insight and shed some perspective on some of the things that were happening today in the Reykjanes area. So let's go ahead and start with our Met Office update. I always like to kind of start there. These good folks that are really doing a lot of the scientific data analysis. So this is our update from today, March 4th at 1:30 p.m. Iceland time. So they lay out a possible sequence of events over the next couple days, that the volume of magma under the power plant region will continue to increase. So they expect that the magma influx from the deeper reservoir towards this shallow 5 kilometer magma body is going to continue. There's no reason to suggest, because we've been seeing this going on now for upwards of 4 to 5 months, I suppose. So that steady magma influx appears to continue unabated. So that could result in either a new magma flow, that's what they're calling the intrusion, where we get magma moving through the subsurface but not causing an eruption. So that's one possibility. And then they also mention even an eruption as the other possibility. An eruption could start at very short notice, even less than 30 minutes. I want to spend a little bit of time breaking that down here in a bit. And then also an eruption is most likely to occur in the area between Stora Stogafeld and Hagafeld. So that's what we know, that the volume of magma is increasing. That's fact. It's very likely that the eruption, should it begin, that it would have very little warning in terms of earthquake activity. So we could see 30 minutes or less in terms of seismic activity that would precede that eruption. And then the most likely location is between these two hills that we've been focusing on the last few days. Model calculations show that the amount of magma that flowed on Saturday from the Svartsengi area, the magma reservoir, into the Sunnuks crater series, so that's the intrusion we have developed off to the east where those hills are on the other side of the road there, was about 1.3 million cubic meters. So they've been able to estimate, based on modeling and using the GPS data, exactly, well, not exactly, but a rough idea of how much magma in terms of volume has moved through the system and propagated to the east into this zone over here. So essentially what happened on Saturday was we had our magma reservoir filled as much as it could, and as more magma was intruding into it, finally the pressure in that magma reservoir was great enough that some of the magma leaked out. It worked its way through these conduits that have already been established to the east, and then I think what happened is it started pushing its way either laterally, laterally through rocks that it hadn't occupied before, or maybe through a pathway that had partially solidified. And in doing so, in order to generate space for itself, it actually had to break rock and generate that seismic activity that we felt there. Just to give you a little bit of context here, this number 1.3 million cubic meters might not mean much to you, but I came up with a few conversions that might make a little bit more sense. So if we just round that down to 1 million cubic meters, that's about the same volume as 400 Olympic swimming pools. So if you can picture a nice big Olympic sized swimming pool and imagine 400 of those, each filled, to the top of the pool rim with magma. That's the idea there. Or another way to think of it is our volume of magma is given by three components. So it's cubic meters. So we would have to have, let's say we have a magma dike or an intrusion of magma that, let's say, is 1 meter wide, about 3 feet if you're in English units. And let's say so that's its width, if you will. Let's say its vertical dimension, in the ground up and down, is 1 kilometer or 1,000 meters, a little more than 3 football fields, if you want to use some American units there. So that's its vertical extent, or its height, I suppose. And then if you think of its length on the map, let's say it's also 1 kilometer long or 1,000 meters, 3 football fields, that would be the volume, right? So if you had a fracture that was 1 kilometer long, 1 kilometer vertically from top to bottom, and had a width of about 1 meter, that would get you to that 1 million cubic meter number if it occupied that space. So maybe that helps a little bit with the concept there. Continuing on with the Met Office update, previously it had been calculated that around 500,000 cubic meters of magma accumulates under Svartsengi in a 24-hour period. All things being equal, the total amount of magma under Svartsengi will be around 9 million cubic meters by the end of the day tomorrow, Tuesday. So we're going to be right back to where we were. So even though we had this exciting event on Saturday that didn't result in an eruption, it leaked out some magma, but it was actually a very small amount. And that's what I talked about during that live stream on Saturday as well, is that whatever amount of magma was propagating and generating the earthquakes, it appeared to be fairly minuscule, fairly small. And this modeling data definitely supports that. So if it's accumulating 500,000 cubic meters per day and we leaked out about 1 million cubic meters, I think you can do the math there and see that after 2 days, we're right back to the magma volume that we had prior to Saturday. We'll be there by tomorrow on Tuesday. In previous events, magma has flowed when the total amount of magma accumulated under Svartsengi is between 8 to 13 million cubic meters. So we're already in that zone, right? We're already within the known window of magma volume that's necessary to generate an eruption. This event on Saturday didn't culminate in eruption like the 3 previous ones did. And I think that's a good lesson to us all, that just because we get the system primed and pretty much ready to go, there's other possibilities other than just an eruption. One possibility, like we saw on Saturday, is that the magma escapes the reservoir, propagates through the rocks at depth, but does not result in an eruption. It takes a lot more buoyancy and possibly more pressure in that magma to get it to move upwards. The magma doesn't know which way, which way we want it to go. It's just going to take whatever pathways are presented to it or what other pathways it can widen potentially, and it's going to head in that direction. And that might be a system of fractures that extend laterally out from the magma body off to the east in this case. Other times it might be fracture systems that can exploit moving upwards. And then it depends on how interconnected those fracture systems are. The fracture systems that it moved through on Saturday to generate those earthquakes may not have had any connection to fractures that were near the surface. And so it was maybe that magma moved through some pathway that was essentially a dead end. Like it didn't have a connected pathway to get to the surface and culminate in an eruption. Might have also been a little bit of a difference in how eruptible that magma was in terms of its gas content and how much buoyancy it had as well. Okay, so continuing on with the Met Office update. Hopefully this is helpful. Therefore, there's an increased probability of a new magma flow or intrusion, and eruption once that amount has been reached. So we're in the window where the threshold can be reached, and it's really just a matter of days and when, not if. However, it can be pointed out that after repeated eruptions in Fagradalsfjall, that's the next system to the east, there were examples of magma creeping up to the surface without much seismic activity. It has to be assumed that it could be the development with the activity on the Sunnuks crater series. So it's possible that if the magma is moving up more slowly, we might not see a whole lot in the seismic activity to go along with that. So the Met Office also has a nice little graphic here, and we've been looking at this over the past few weeks as well. This graph shows, with each color, it shows the magma inflation and the magma volume increasing with days, and then when each little line ends, that either ends with an eruption, like we see with the 3 stars here. That's the December, the January, and the February eruptions. So how many days it took before those inflation cycles ended with an eruption. We, of course, back in November had an inflation cycle that ended with an intrusion that created a lot of earthquake activity, and the dike that we now know lies just northeast of Grindavik, right through the town and then off to the northeast. And then our current trend here is this red line. And so notice this last data point is a downturn. So because we had some of the magma leave the magma reservoir and intrude into the rocks to the east at depth, that meant that there's a little bit of a net movement down. But notice it's only, it's only about this one-ish million cubic meters of magma. So it's not a very significant amount. Had this thing like really dropped down, that would have been a lot bigger of a transition. But really, this thing, what we'd expect this to do over the next couple of days is this going to resume its trend and start heading upwards, and kind of continue this slope that we saw preceding that. So that's it for the Met Office there, giving you a little bit of context. If we look at earthquake activity over the past 24 hours, fun little earthquake down here, a 2.0 that happened. This is actually pretty recent that this one happened, but at a considerable depth. Again, 1 or 2 earthquakes all by themselves, not alarming. We're, of course, focused on this region in here. On Saturday, a lot of the activity was happening just north of Hagafelt in this region here, and it looked like for a period of time that might be the most likely eruption site, but we never saw those earthquakes getting shallower. They were all pretty much in that 5 to 6 kilometer range, and they never reached a much shallower level than that. So you can see some of the earthquakes happening more recently, very small, but similar depths, 4 to 5 kilometers or so. And these are all underneath magnitude 1. So again, mainly smaller quakes here, a little flurry of ones off to the east, but again, nothing to suggest magma is moving into that area. I did notice this little cluster here earlier today, just east of this mountain Kelir. And these were all shallow quakes, but these happened literally like maybe, 16 or so hours ago. They were quite shallow, but I think it's just a little flurry of tectonically induced quakes due to stress release, not seeing anything there. Again, before the magma is going to come up in some other place, we're going to see a lot of warning signs in terms of earthquake activity and GPS movement, ground deformation as well. So the recent round of earthquakes doesn't seem to show us much. I thought it was worth talking a little bit because I know on one of the Live from Iceland live chats with their webcams, there was some talk based on what Amanda Joe mentioned to me about the next event possibly having no earthquakes. And I think that's pretty unlikely that we actually see like no earthquakes. In order to get that magma to the surface, it's got to follow some pathway. There's not a big wide crack on the ground in Iceland that extends down and connects directly to the magma body. We either have these partially solidified pathways that have been used in the past, or we have that existing rock that's present there. And so any sort of future eruptive event is going to have to break rock and generate earthquakes. It might not be as much in terms of earthquake activity as we've seen in the past prior to an eruption, but we still should see over short periods of time and spatially near that eruptive vent, we should still see some seismic activity. That's my analysis on that. A couple other things. So right now, it's I didn't get to this update till a little later. I had classes and a student I needed to help, but it is definitely nighttime in Iceland. But during the day, earlier today, on a lot of the webcams, I'll show you this image that a viewer sent me. There was some concern from some viewers about images like this, where you can see the older flow field here. This is the January 14th flow field, greenhouse. There's the edge of Grindavik there. And you can see this sort of murky haze there. And I think people were wondering if that meant there was some activity going on, but this is all completely normal. This lava field is going to be degassing for quite some time. This bluish color here is some of the sulfuric gases coming out. They also apparently had some rain earlier today. So when you combine the rain seeping down into the lava rock, that's going to create water vapor that's going to rise into the air. You're going to see that. But this is all very, very normal. This is not. So I think when people are watching the webcams, and because of Iceland's kind of crazy weather and temperature conditions, it's fairly easy as you're watching the live cam. You might see something right before your eyes develop, something changes. It looks more, the gas looks like it's increasing a little bit. And of course, we're all eagerly anticipating possibly that next event. And so it's easy to get sort of wishful thinking and sucked into that. But this is, I'm just letting you know, this is all completely normal behavior and phenomena related to these lava fields that are cooling. This is going to go on for years, right? This specific lava field behaving this way when the temperatures and the moisture content is just right, and the winds potentially as well. This is going to go on for quite some time. So hopefully that adds a little bit of context there. Remember, rock is a really good insulator. So it's even though it's cool at the surface, you could walk right across this thing. You could put your hand down on these rocks, and except for the places where there's fractures, where it's connected to the hot rock below, it's going to feel cool to the touch, even though it's less than 2 months old. But a few centimeters, inches down below that, it retains a lot of heat, and it takes a long time for this stuff to cool. And so we expect to see this thermal property. The snow is not accumulating on it because it melts as soon as it hits this patch of lava. And so there's lots of water vapor coming off of it, and it's still releasing some of those trapped volcanic gases as well. So all very natural, all very normal, and nothing that signifies anything more of more importance than that. The GPS data is really interesting, and I'll be honest, I haven't had the time today with the weekend and classes and such to really dive into this, but I do want to show you some interesting trends. I might be showing you more observations than any sort of interpretation because I just haven't had time to excuse me, wrap my head around this. So let's start with Svartsengi, and we'll look at what happened on Saturday. And there's a couple of trends here. So our Saturday event on these graphs is going to be this last little tick here is around like March 1st. And so we want to see the very right edge of these graphs. So no real noticeable change in the north-south movement of the Svartsengi GPS station on Saturday. But there was a little bit of a down drop or movement to the west on the east-west plot. So this station has progressively, with each eruptive event, has been moving westward. And that trend continued, even though there wasn't an eruption on Saturday. If we look at the up and down data, this is interesting. It actually looks like it's increased a little bit. So we don't see any sort of net movement down at this particular station due to Saturday's event. Let's look at a couple other stations here before we try to, and I don't know that I'm ready to break this all down. So this would be the next station. And let me kind of show you the map here. So I have on my Google Earth here. So that station is right here, the one we just looked at, just north of the power plant. The next one we'll go look at is way over here, the Eldvarp station. I think one I want to look at here is the Thorbjorn station here. And then we might look at this one here as well, which is probably closest to where that flurry of earthquake activity took place. So let's go check those out. So the Eldvarp station off to the west, again, no discernible change in the north-south motion, no discernible change in the east-west motion. This location has been, since the February 8th eruption, has been progressively and steadily moving to the west. But there is this interesting downturn here. So the movement of the magma as it intruded into the rocks to the east of the power plant area, it does look like there was a bit of a down drop in this station's elevation, as the whole system maybe just, wasn't really, I don't know if I'd call it true deflation because it was so small, but it really was a small deflationary event because you moved some of the magma's volume from out of the centralized reservoir and injected some of that magma into rocks off to the east. So it was a volume decrease of what the Met Office calculated was a little more than 1,000,000 cubic meters. And so you'd expect with that much magma, although small, moving out of the system to see some deflation. And we do see that at some of the GPS stations, just not as much at that Svartsengi station. This station here, let me show you where this one is. This is one up here, right along the highway and just north of this flow lobe from the February 8th event. So NORV station, if we come back to that one and look at that, a little bit of a northward movement. So there's that little blip right there from a little bit of northward movement. If we look at the east-west plot right here, you can see a little bit of westward movement. So it moved north and west. And then look at the up-down motion. There was definitely a little bit of movement there as well, a little bit of upward movement there. So different than what we saw at Eldvarp. And again, I haven't like totally wrapped my head around this. So this could be magma that had moved to the east, filled that northeast southwest dike to some degree, and maybe caused a little bit of regional uplift, possibly. Yeah, I have to kind of look at a little bit more than that to get the big picture. But these are just some interesting trends, and I'm interested to hear if other people have figured out or can come up with some ideas here as well. If we look at our last GPS station, again, we can look at all of it, but I just want to look at a couple here. Up here on top of Mount Thorbjorn, let's go to that one next. And this one shows no north-south movement on Saturday, a small bit of westward motion. Okay, so it moved a tiny bit to the west, and that's consistent with a lot of the stations in that area. And then like the Eldvarp station, it also showed a little bit of a down drop and definitely some stagnation there, right? So that deflationary trend, that just slight downturn in the elevation shows up there as well. So, but feel free to look at these and play with them. Again, I haven't had the time to fully digest and look at all of these just yet. But that you can see on some of these, you can see, looking at that far right edge of these graphs, that's going to show you that March 2nd event. And some of these do show some up and down motion. Some of them show east-west motion. Some show north-south motion, and then different combinations thereof. So, okay, what else do I have here for you? One last thing I guess I want to mention here. This happened today as well. And I will put a link to this here. I'm not allowed to show the actual, any of the footage from the drone flight because it's copyrighted, but there's a videographer in Iceland named Isaac who has his own YouTube channel, and he has some drones and some thermal drones. And earlier today, he had flown one of his drones and was live streaming and was looking along the base of this hill, Stora Stogafelt. I think he was somewhere on the west side of the hill, if I remember correctly. And what they were seeing with the thermal drones was a few places right along the base here where there were what they were calling hotspots. Basically, with the thermal drone imagery, they were able to see that the temperature there was elevated. And there were also parts of the hill where there was water vapor coming out. It did not look to me like it was volcanic gas. It looked like water vapor based on the color. It wasn't that bluish gray that we typically see with the sulfuric gases. And he wasn't necessarily trying to interpret it. He was just showing an interesting phenomenon and feature. But in the live chat, there was lots of speculation and lots of folks trying to figure out what was going on. I did watch that for 10 or 15 minutes, and so I can give you my short take on that. I don't think that it shows anything about what's happening. I think the use of thermal drones, and I know there's several individuals in Iceland and other places who think that they're, well, first of all, they are cool. I don't want to dismiss that. Using thermal drone imagery is very cool. I think using thermal drone imagery on these recent lava fields is very interesting. I think using them in a geothermal area like we do in Yellowstone or places where there's hydrothermal activity like geysers and hot springs can be very helpful and informative because there can be dynamic changes in the system where the heat flows to different places. But using the thermal drones in an area as a means of predicting or forecasting eruptions, I don't think is very valuable because the magma is still 4 to 5 kilometers down in the crust. It has not established pathways to the surface. Of course, we're going to see hotspots in this area. There's still places. I've been to Iceland 4 times, and you can wander out in the Reykjanes and find some little hill and put your hand over a crack in the rock and feel heat or see steam on a cold morning. So recognize that what you see visually is partly the air temperature. It's partly the humidity of the air and how much water vapor is coming out of cracks. What else? And the ground is hot. There is a power plant right here that's tapping hot water not that far into the subsurface. And they're pumping some of that water over here to the Blue Lagoon, and people are taking a dip in the hot springs there. There's other places on the peninsula where there are hot springs and power plants. So of course the rocks in this region are hot at depth. Of course these lava flows that have just erupted over the last few months are still quite hot just below the surface. And I think we should also recognize that we've had 4 or 5 months of fairly intense to maybe not so intense, but regular earthquake activity. And the earthquakes that have happened in this region, particularly those on November 10th, have broken rocks, have shook the rocks, right, with the seismic energy, and have created new pathways, new fracture systems, interconnected fractures maybe that weren't connected previously. And so the permeability of the rocks in some places had been probably enhanced to some degree. The permeability in other places, maybe there were fractures that were connected and then the shifting and the earthquake activity took them and disconnected them. So you might have slightly reduced permeability. But the point is that things have changed here. And so places where we might not have seen a thermal signature or heat coming out of the ground maybe now show that because of all the changes that are going on. But none of those observations with the thermal drones, until that magma gets really close to the surface, the thermal drones are just showing you what's taking place close to the surface, right? So it's not a clear indication of what's happening at depth. I would not want to look at a anomalously hot or warm region of surface rocks and project that to be a likely location for an eruptive event, because it doesn't work that way. We want to stick to the seismic data. We want to stick to the GPS data. That's going to be the better indicator of not just when, but where and how much lava could erupt at any given time. So I'm not dismissing the attempts. I think it's cool. Like, it's visually cool. Like, if I had the money and a thermal drone, like, I'd go fly it around over there. Heck yeah. And I'd look at the lava flows cooling and I'd look for these cool things. But I just don't want us to jump to the conclusion that it's indicative of something about to take place. It's not a predictor of eruptive behavior or future eruptions in the region. So hopefully that helps a little bit, and hopefully I made that pretty clear. Last little bit of news, and then we'll wrap this one up. I think, Yeah, the only little bit of news item I had here was a article from the Met Office. Benedict Ofigson talks about a lot of the things we mentioned here. That is a little over a million cubic meters per second, and he mentions that that's about 1/9 of what was erupted on February 8th. So it really was, and that was again February 8th was a day-long eruption at best, and so it was a very small amount of magma that propagated and moved through the subsurface this past Saturday. We think there's every chance, this is his quote, that something will happen again soon, probably this week. I would agree that we took a step back in terms of magma volume in the system, but now it's back to pretty much that window of eruptible magma. One possibility, he says, is that there's less room for the magma to enter this corridor, but we cannot rule out that it will recover and that there will be a large corridor or a large eruption. Yeah, so every time one of these little things happens, the dynamics of the subsurface system is changing, and so it makes it increasingly more difficult to predict or forecast, that's the better word, where it's going to erupt, how much is going to erupt, with any sort of certainty. Yeah, so that's a good little article here. I'll make sure this is in the links. I'll also put Isaac's drone YouTube video footage in the links if you want to see some of the thermal imagery he did and the things I was talking about with the hotspot near the base of Stora Stogafeld. But thanks to Amanda Joe for sending me a lot of this information. Appreciate it. As always, she really does so much work in helping me get these updates prepared. It makes it so much easier for me to just take what we know, analyze a little bit of it, and then give you my interpretation. I do have some emails from folks with some other graphics and videos and interpretation that I haven't been able to get to, so I'll try to digest those soon and then get back to you. So the last thing I'll say signing off is, well, what's next? Well, we know this intrusion on Saturday sort of moved the timetable for the eruption back a day or two because some of that magma basically leaked out of the system, but we continue to have magma influx into this region here, just a little bit southwest of the power plant. And it clearly has a conduit off to the east or northeast where it intersects this dike system of fractures that is formed. And so right now we expect that next eruption to be between these two hills. And because the timetable went back a day or so, that means that probably later this week, could be any time, could be in 20 minutes, could be tomorrow. But I would guess somewhere between Wednesday, Saturday, maybe Sunday at the latest of this week, we should see something else happen. That could be an eruption. That could be magma leaking out, maybe finding another pathway, and maybe not even erupting again. So there's a couple possibilities there. But I thought Saturday's event was a good reminder that not every seismic swarm and primed magma system results in an eruption. Many of those end in a magma intrusion, or what they're calling a magma run in Iceland. And so with that as a little bit of food for thought, I'll go ahead and sign off. Thanks again for joining me. Thanks for your support of the channel. Thanks for watching. I appreciate all my viewers. I appreciate learning with you. I hope you enjoy the process that we go through together. I hope you feel my sincerity and authenticity in sharing this with you. And we will see what happens next. I'll for sure put together another update or possibly a live stream later this week if something were to happen. Obviously, I have my classes also going on that are the #1 priority, but I'll work around those as best I can. In the meantime, I have some other videos I'll put up soon, some more of the videos from Bryce Canyon National Park, some of my field-based videos, and I do have plans to start recording some of my Geology 101 lectures and putting those out as well so you can learn some of the basics of geology and increase your knowledge. So thanks again for learning with me. Take care, and we'll see you next time. Bye now.